I would say this question falls under what looks crazy, but is not. The 5 mark allocation there, I would say it's mainly because of all the writing we're gonna be doing. You see,
Oh yeah, I
because
can see already
yeah,
with the first question. You basically
yeah,
copy it, but you put in a six, a six, six.
yeah. But then wait, I also think I chopped off some of the part of the question there. This was IEB 2014 something something. Was it exemplar? I think so. Standardization project. Oh my goodness. Yeah, there we go. I just want to check what was written on top here. You see, because you see on the image here, it's like a bit chopped off.
Oh,
So I
yeah.
want to see what was written there. You see this thing? Oh, open sesame, please. Oh, there we go. Okay, yeah. Oh, yeah, I definitely did chop off part of the question. They're talking about this person here, so let me crop it out and see what is up. So this is like this, like this, save, and then this we paste, scroll on top there. Yeah, so question 13 says the following. Philip is designing a large pool, is designing large pool troughs in the shape of rectangular prisms. And then it says here with an open top as shown in the diagram below. Then it says the table shows some standard sized troughs and their surface areas. So fish trough 1, 2, 3 until a specific one. So they have surface area here. So remember, surface area is just the dimension, it's just like the area of one side plus the other side plus the other side. And then each of these sides, there's 2 of them, you see. But then anyways, with this shape, we all know that they said the top is opened. So the surface area, I think with this image, right, we would want to maybe have looked at it like this, you know. I mean, if it's open, then we should be able to see the inside, you see.
Yeah.
Yeah, something like that. But that's not very nice. Like, why in the world is it like being funny? Anyways, it doesn't matter. Here we are. So with this being said, they said here we have the surface area, right? Here the surface area is like 44. And then this is what they did. And then the next one is 83, going on and on and on. So it's just almost like a formula here. And we can already trace it, you know. Here there's some kind of a sequence. You see, 1, because this is 1. 2, because this is 2. 3,
Yeah.
because this is 3. 5, because this is 5. So whatever this one is going to have, where there's 5 here, we're going to put M. Where there's 5 here, we're going to put M. And then here already, where there's 5 here, we're going to put M. You see? And then there are certain things that are staying the same. They're just 2s here. They're just 2s there. They're just 5s here. And then here, this is 1, 2, 3, 4, 5. So here we're going to have M. They're just 3s here. So we're also going to have a 3. This is 1, 2, 3, 4, 5. So here we're going to have M. These are all just 5s. So it looks like it's just a matter of following the trend here, right?
Yeah. Definitely.
Yeah, definitely. So with what we have to do for the first one, they said, find the value of A plus B plus C in terms of M. So you see here, they're giving us 5 marks for writing out a lot of stuff, which is what we mentioned in the beginning. Because we're not necessarily like, you know, doing like very crazy stuff, you get. So for example, here for M, for A, we already know where there's, we can do them individually first and then add them. Yeah. And of which that's something you can always do in your on your answer sheet. Always be comfortable doing things individually before you like just throw them into the equation. So here it's 2, and then where there's 5 there, we can put an M. This is 3 times M. So that's for A, right? We can try and simplify it, obviously. This is going to be 2m squared plus 3m. You see, and then when you cannot do anything, you move on to the b. B would have been 2 and then m squared plus 5 with m there. No. Yeah, it's 5 because here you see the 5 is everywhere. 5, 5,
Yeah.
5, 5, 5, 5. So that's going to be 5m, meaning that this is like 2m squared plus, oh yeah, I made a mistake, you see. It's supposed to be 6. Classic mistake. I realized it when I was about to multiply this and get a 10.
Yeah.
Yeah, so with the C, we can see same idea. Let's just see what stays the same. This is like 1, 2, 3, 4, 5. So here it's going to be a M. Let me actually maybe not write it down here. Let me write it up here. So for C, we're going to have M plus 3 because all of them have 3's here.
Yeah. And then M plus
1, 2,
5.
3, 4, 5. So it's like M plus 5. And then M times M is like M squared. M times 5 is like 5M. 3 times M is like 3M. 3 times 5 is like 15. And then this is like M squared plus 8M plus 15. There we go. So we have all 3 expressions for A, B, C, and D. I mean for A, B, and C. So they said we should write it in its simplest form though. So we should write all this in terms of M, place your answer in its simplest form. So automatically here, we can already see that A plus B plus C. So we have A here plus B plus C, just gonna be equal to this part first, 2m squared plus 6m. Luckily we're plusing, so brackets won't be an issue. 2m squared plus 10m, and then m squared plus 8m plus 15. Meaning here, you see there's like terms. 2 plus 2, that's a 4.
Plus 1.
Plus 1, that's a 5. And then 6 plus 10, 16. Plus the 8, 24.
24.
And then there's the last one. And then from here, we could try to like factorize, maybe. We could try, you know. So us trying to factorize here, you can always look at trying to do it via grouping. So the first thing is you want to multiply these two. 5 times the 15, that's going to be 75. And then you want to split the 75 into factors. That will give you a 24. So yeah, that one is a bit interesting. So you can see, okay, 1 and 75, that's not going to give you 24. 2 doesn't go in here, but then let's try 3. Does 3 go into 75?
Yes, 25 times.
Oh yeah, but then 5 times 3 won't also give us a 24. So I don't think this one will work. And then 5 times the 5 and the 15 will give us a 20. So this one cannot be factorized the way we want it to be. So this looks like this would be the simplest form.
But Levi, can't you just put 6 in M? Or do you have to solve M first? Then put it
No,
in
we don't have, yeah, we don't have to solve anything. We just have to put it in its simplest form. Because you see our expressions here were all in terms of M. A was in terms of M, same was this, same was this. So when we have added them, they're just going to give us D, which is what we have done. You see, all these added up is giving us D, and we cannot do anything else here. We're not solving for M, you see.
Okay. So that's why you also can't put M as 6.
Why did you want to put M as 6?
Because it was going 1, 2, 3, 4, 5. So you go 6.
Yeah, well, yeah, but then that's why they put a variable here to show that the next one can be anything. Because it's like 1, 2, 3, 4, and then absolutely anything. So this could be 6, it could be 7, 8, 9, 10, it doesn't matter. You get it.
Yeah.
Yeah. So it's just there to show that the trend is there. This is just increasing by 1. But then this is to say that this could eventually be anything. But then it still just follows this trend here, where you see the 1, 2, 3, 4, 5, eventually here it will just be an M. And then same here, it will eventually be an M. It will eventually be an M also. So with the B question, let's see what the B question has. Like question B of this image. Let me crop this thing. Try and see what we got. Do this. Do this. There we go. So let's see. With this B question, right? It says the following. It says Phillips ship troughs are all built using the surface area formula A plus B plus C, right?
Yeah.
Then it says, what is the surface area of a trough so that the trough can hold 1,512 meters cubed of water if filled right to the top? So this is an interesting question. And this is the kind of question like we've read it once, but it's like, it's not making any sense. So might as well read it again. It says, Phillips fish troughs are built using the surface area formula A plus B plus C. We see that the surface area formula is A plus B plus C. And then we can see that whatever that surface area formula is, it's this here. You see, this here is our surface area formula. So we can even say here, this is the surface area formula in terms of M. That's how we can write it out. M in brackets here. Surface area formula in terms of M is equal to this. So we have a surface area formula. That's what A basically gave us. Do you see?
Yes.
Yeah. We can even test out this formula, you know, because this is saying our surface area formula, wherever M is just going to be the number here, you see. So if the number here is like a 3, let's throw 3 into our equation here and see if that number comes out as 132. Let's just try it out. Like put a 3 there and put a 3 there. What answer do you get?
132.
Perfect. You see, so our surface area formula works. If you put 1 where M is, and you put 1 there as well, you're going to get 5 plus 15, which is like 20, and then plus the 24, which is 44, which is what they have over there, you see. So do you see that the M here and what we did is just giving us a surface area formula?
Yeah, and I'll remember that if they give me an M, I'll keep it M. Don't put a number.
If they give you a variable, just keep it a variable. So here we're now reading again, right? It says the Phillips fish troughs are all built using the surface area formula. As we saw, we have that formula. Now with that formula, they said, what is the surface area of a trough so that the trough can hold this? So this is volume.
Yeah,
you see, because of the M cubed there. So they've given us a volume of water if it is filled right to the top. So this is quite interesting because I mean, like they've given us the volume of the water, right? And because they've given us the volume of the water, we have to be creative here. So remember here, we said surface area just means, if you look at the image that we have here, let me actually draw it a bit nicer now. Or let me just copy it and then we can analyze it again. So if you see this 5-mark question, they just want us to like think a bit, not think hard. They just want us to think creatively, but not even too creatively. Because remember, if they've given us volume here, we have to now analyze the image and think to ourselves, okay, fine. I mean, like for the volume here, what is going to be contributing to the volume? So let's even try and make this shape very close to what we have already. So let's do this. Yeah. So if you look at what we have here, right? This image, they said it is open. You see, so I think the one thing is, I don't know why they didn't just give us an image that shows it's open. You see, so we can just draw it on our own. So this image here, They said it is open. So let us do what we gotta do. Oh, well, let's make it actually really nice. I know I'm like being extra here, but you know, I don't see why not. Let's just do this, get this length there, and then that same length, put it over there. Over there. Yeah, yeah. And then let's get this length over here.
That's small.
And then, yeah, so that our image can look, you know, nice. Do that. And let's stretch it a little bit. There we go. And then from one end to the other, we're gonna have this thing over there. Nice. Okay, so we have our image, right? And the one thing to emphasize here is that our image is open. So if you're looking at our image that's open, right? When they were getting the surface area, remember, with the surface area, you have to remember that the formulas here, it's not a coincidence. You see that this formula has a 2 and a 2 there. So if you look nicely, right, in our image, we have 2 sets of sides that repeat, and then the bottom only has 1, you see. So this is, if you look nicely, right, this shape, you have the same shape here, right? And then the front, you have the same shape at the back. You see, that's why there's a 2 over here and a 2 over there, to show that there's a side that's being multiplied twice, there's another side that's being multiplied twice. And then for the bottom, you can see this does not have anything multiplied twice, you see. So it's just the bottom there. That's how they got surface area, because they just took the areas of the sides multiplied by 2, areas of the front and back, or the area of the front rather, multiplied by 2, because the area of the left here is the same as the area of the right. The area of the back is the same as the area of the front. Do you see?
Yeah.
Yeah, so that's what we can maybe try and think to ourselves. That's what they were doing when they were getting these surface areas. And then when they added the left, right, back, and front, they just added the bottom afterwards. So without overthinking it, with that being said, right, the volume, we know that it is technically going to need to be, yeah, I think the volume here is going to be quite interesting, because for 5 marks, what is the surface area of a trough so that the trough can hold that much in terms of water? Let's see. So we can see that all that's happening here is the troughs are getting bigger. So we have different sizes of troughs. And let's see, I just might double check something. And then, yeah, remember, this is more like a square. Hold on. Hold the door. Oh, wait a minute. Wait, no. Let's see the question again. Phillips fish troughs are built using the surface area formula A plus B plus C. What is the surface area of a trough if it can hold this much in volume? Huh. Yeah, this one is kind of tricky. But I mean, like, if we're creative, right, we could work something out.
Because I would have, if it was a area, I would have made it equal to that equation that we made.
Yeah. I think the whole volume factor here is what is a bit of a problem. But then it's a 5-mark question, so we also may not want to overthink it, because there's really no reason to overthink it. You're not. Let me see. Let's try and think creatively based on the formulas we were given down here. So looking at the formulas we're given here, I mean, like, we can already agree that this was representing a front and a back, or maybe a left and a right. This also was representing a front and a back, or a left and a right. And this one was definitely representing the bottom, you see. So let's maybe label this bottom. Let's label this sides. Let's say left or right. And then what is the shape of these troughs? Did they give us the shape of these troughs? Maybe. Rectangular prisms. Well, if they're rectangular prisms with an open top as shown in the diagram. If it's rectangular prisms, you see they said here, rectangular prisms. But then the thing now is these rectangular prisms, they're not all exactly the same. So what does that tell us now? Because I'm like the areas, okay, what we know is if we were to look at this image normally, right? If we had, let's say, a rectangular prism, right, and we wanted the surface area, would have said, if we gave these dimensions, would have said length, okay, would have said length times breadth times height, you see. So this would have been length, this would have been breadth, this would have been height. These would have been the dimensions. And then the surface area would have been length times, would have been like length times height. But then we have two of them, right? Yeah, so let's just write that a bit better. So we have two of them where we say length times height. And then that's for the front and the back. And then for the left and the right, would have said two of them, but then it's like height times breadth. Do you see?
Yeah.
And then for the bottom, would have just said length times breadth. But instead of having two of them, we just have one because they said the top is open, remember?
Yes.
Yeah.
Makes sense.
So yeah, so let's try and look at that from this perspective here, because if you look at what we have mapped out up here, right? This here, length times the height, we can already see here, it looks as though the length is being determined by, yeah, because if you look at our brackets here, our brackets, definitely the first bracket is for length, the second one is for height. And then here though, if we look at it nicely, yeah, this is quite strange-ish. Well, not that strange, it's just like a bit annoying looking at it. And for 5 marks, I would say in an exam, you would maybe want to look at this one last instead of like looking at it before. Yeah, because it looks like, let's see here, 2, and then length times breadth. This is like SA. So the 2's we have in front here, these 2 could represent that 2. This 2 could represent that 2 over there. And then let's see what we can con out of this question, because it's kind of crazy. Length times breadth. Well, here there's nothing being multiplied together, so. Oh yeah, but wait, if you like factorize this here, it looks as though you have a 2. If two things are going to be multiplied by each other in here, it's gonna be, if you take out a 1 here, you would have 1 plus 3 in there. So this could represent length, this could represent height. For this one, here you can take out a 1 as a common factor. If 1 is out, you'd have 1 plus 5 over there. So this could represent length, or okay, this would represent like height and another dimension. And then here, this is already factorized. So we can already see that one of them represents the what you may call the length, maybe, and then the other one represents the height. Yeah. Because I mean, like whichever way here, if you multiply, if you do whatever you're going to do, yeah, it doesn't look like we're gonna have much. But let's see here. So looking at these two, right, and looking at these two, amongst these two, the only thing that's common here is the h. There's an h here and the h there. So we could think to ourselves the height is a 1, because you see there's one dimension there, one dimension there. So we could think to ourselves our height is a 1. And then here we have a length there. You can see that the length here has a different value compared to the breadth. You see the breadth has been given the value 1 plus 5. Let's maybe put 1 plus 5 in green there.
6.
1 plus 5. Yeah, so for now we can just leave it as 1 plus 5. So we can already see where we see like the 1 plus 3 here, it's representing the length. where we see the 1 plus 5 here, it looks like it is representing the breadth, you see. So that when we're looking at this thing here, we said here we should like one way or the other, right? Let's see. I mean, here it's supposed to be length. Wait, why is this height now? Length. Yeah, this is supposed to be length times breadth. This is an error because the bottom part is length times breadth, of which that makes sense because do you see that here we have the 1 plus 3 here, and then here we have the 1 plus 5. You see, because do you see that the 1 plus 3 here is representing the length, the 1 plus 5 here is representing the breadth, and then here we have length times breadth. You see?
Yeah.
Yeah. So it's almost like we just reverse engineered this question. So the height here, we figured it out to be a 1 because where there's a 1 here, there's a 1 there, which is just like here, height and height. And then where there's a 1 plus 3 here, here you have a 1 plus 5, which is representing, here you would have like a 1 plus 3, and then here you would have a 1 plus 5. And then at the end, you have that L times the B there, which is being represented by the 1 plus 3 and the 1 plus 5 over there. So our dimensions, we can already see that we said the length is just 1 plus 3. That's the length over there. The height, we figured it out to be a 1. And then the breadth, we figured it out to be 1 plus 5. So we just color code them the way we figured them out. 1 plus 5 over there. 1 plus 3 over there. So if we can draw the shape nicer after all this madness, drawing this shape nicely, we'll have these dimensions, right? Height, breadth, and the length. So those dimensions we got here, the height is just a 1. This is just 1 plus 5. And this is just 1 plus 3. So with this being said, right, we can already see that if they've given us an actual volume to work with now, they said here, what is the surface area of a trough so that the trough can hold this much volume of water? Yeah, that's quite interesting. That's quite interesting. That's quite interesting. I mean, we can think to ourselves, I mean, like right at the bottom here, right? We can, it's just going to be a bit, I don't think it's going to be a bit difficult for us to do what we have to do. We kind of just need to almost psychoanalyze the question as well, because from A, B, and C, we'll be able to maybe see what is the length, what is the breadth, and what is the height, but in terms of M. But then the issue now is anything in terms of M is not going to help us because here we have been given an actual value to work with.
Yeah.
Okay, wait, I think what we can do is let's see what the volume is here. But then still, what is that going to help us with? The volume originally here is just this times this times this. This is going to be 4 times 1, which is a 4, times 6, which is going to be like 24. That's the volume. And then we know that if we're looking at what we have going forward, this could still easily be representing length times breadth. So I think, let's see here, this could easily still be representing length times breadth. And then because the 1 here was the height, we can assume that the height here would be a 2. And then here, this could still also represent length times breadth. And because the height here was a 1 for the original one, here we can assume the height will be a 3. Going on and on and on. Do you see what I'm trying to say for these ones here? Like the trend that we're seeing. Yeah. So for each of them, it looks like this represents the length, this represents the breadth, and then the number here represents the height. Because that's the trend from what we saw in the beginning. You see, this represented length, this represented breadth, and then this represented the height. So, I mean, for what we can do down here, this would represent the length, This would represent the, wait, that's supposed to be a 3. This would represent the length. This would represent the breadth. And then M is equal to the height. Okay, okay. That is quite interesting. That is quite interesting. So let's see what our dimensions would look like. Because here they're asking we should get the surface area. Wow. Wow. Let's see what the dimensions of our shape looks like in terms of M. Maybe that's going to help us. So according to this, the height is M. And then the length is M plus 3. And then the breadth is like M plus 5. And then we already know that the volume of this shape would be length times breadth times height. So it would be length times breadth times height. Do you see it?
Yeah.
Yeah. So if the volume is 1,512, 1,512, right? This is going to be M plus 3, M plus 5, and then the M there. So here we could think to ourselves, why don't we just solve for M? But the unfortunate thing is, I mean, like this value of M is going to be like a trinomial, which is like, no, it's not going to be trinomial. It's going to be a cubic expression. So this is like M squared plus 5M plus 3M plus 15 with M outside, which would be M squared plus 8M plus 15, which would be M cubed plus 8M squared plus 15M. And then if you try to like factorize that, you would get, yeah, like M cubed plus 8M squared plus 15M minus this, which is like, it's just out of bound. Yeah, so I think with this question, we can check the memo, see if it's anything that you have like looked at so far, because anything that has to do with cubic expressions, right, it's going to be dealing with like calculus, of which I don't think you have started with calculus yet.
No.
But I think for interest's sake, let's go and see what we have here, so that if we psychoanalyzed it too much, then we can just get clarity before just going on forever. So that was question, I think it was question, let's see here. Question 13. So moment of truth. Question 13. Maybe it even had a simple solution, because I mean, like out of 5. Oh wait, we were in the right track.
Yeah.
But did you see we mentioned calculus.
Yes, and we haven't done that yet.
Yeah. So from here, right, all you would have had to do, like when you would have learned calculus, is all you would have to do in this situation here is you would need to find one solution for M using trial and error. You see, meaning you would put in values for M here and see which one works out. So according to like the memo, I mean, like without over analyzing anything, like according to the memo, 9 was one of the solutions. So once you had gotten the 9, after you have learned calculus, you would be able to like factorize this whole thing here, which eventually gave us a value of M, which is 9. So you can imagine, as long as we get a value of M, which is like 9. So here we would have gotten M is equal to 9. As long as we get a value of M, which is 9, we can now find the surface area, which is what they asked for. Because our surface area, to get it, we just need a value of M that we would throw into our surface area formula. You see? So in our surface area formula, we would have thrown in 9 where M is, which would have given us 5 times 9 squared, blah, blah, blah. And then we would have gotten the answer 636 over there. So I think in terms of this example, what we can take away from it is being able to see trends. Because here, in as much as we started in the beginning here, I think whatever we did maybe started to make maybe small sense when we started to see that, it's just length times breadth and then times by 2. Yeah, and then height times something times by 2. And then here, because there's only 2 things, whatever these two things are, has to be this. And then we saw that here, the 1 was the height. So I mean, like here, if this is the height for the next ones, this would be the height. The 3 would be the height, going on and on and on. And then that's where we ended up with this. But then the cubic part, we said that's not in the, you haven't learned that yet, so you don't have to worry about it. Cool.
Yeah.
Okay. Fun time.